The first learning objective in our standard, all about momentum, is I can represent a system of multiple objects with initial conditions with vectors for velocity. So this one should take us no time at all to go over. Really simple idea. What we're doing is representing, so that's going to be drawing, a system of multiple objects, so it's just that your system has more than one object, with initial conditions with vectors for velocity. So we're just drawing two or more objects and showing the velocity with a vector. That's the simple idea of it. Let's take a look at the first example right here. So we have two balls moving with initial velocities. The ball on the left is moving with a positive 6 meters per second, and the ball on the right is moving with a negative 3 meters per second. So as I have drawn it here, first off, we always on these problems like to define what is positive and what is negative. So to the right is positive and to the left is negative, which I already included over there. So the ball on the left is moving to the right, which is the positive direction, at 6 meters per second, and the ball on the left is moving to the ball on the right is moving to the left, which is negative 3 meters a second. One thing I should point out, though, is that we are not going to draw, at least in this class, we are not going to draw velocity vectors directly in the middle of the object. And the reason for that is because we just learned how to draw free body diagrams. And free body diagrams, you put the force vector, starting with the tail, in the middle of the object that is getting the force applied to it. So we want to just distinguish it from force vectors. We want to make sure it's obvious that this is not a force, just so that the reader of your diagram doesn't get confused with a free body diagram. So that is why for this example, I have put the force vectors above it, simply to indicate that this object is moving and not experiencing a force. So for tips of drawing this, that was the very first one I said, don't draw the vectors acting from the middle of the object, because we typically do that with free body diagrams and forces, and we don't want to confuse whoever is looking at the diagram. Next thing is, of course, we need to assign a positive and negative direction. With most physics problems, you should assign a positive and negative direction. Otherwise, you might get confused which way is which. And don't forget negative signs for negative motion. In the last example, I had it already laid out for you, but let's do it together then. A truck is going west with a speed of 30 meters a second. Probably should mention here, a lot of physics problems relies on north, south, east, and west. This would be like if you're looking down on a map. North is typically up on the map. East is typically to the right. South is directly below, and then to the left would be west. If you have never seen what a compass looks like, this is what a compass looks like. The north, up, east is to the right, south is down, and west is to the left. I always learned it by never eat soggy waffles if you're going from clockwise around it. Anyways, the importance of that is that a lot of physics problems winds up using those coordinates, those directions, for indicating the directions, and this problem is one of them. So a truck is going with the west with a speed of 30 meters a second. So let's draw that to the right. This is going to be our truck. Absolutely amazing truck. And it is going to the west direction, which usually would indicate that it's going to the left of our diagram. So we'll have this go to the left, and it's going into the left at 30 meters a second. Now we need to stop and think, what's going to be positive and negative for this case? We could make to the west positive, but it kind of flies against convention. Normal convention is to make to the right positive, so let's just go ahead and do that. That would mean that this truck has a negative velocity, actually. So truck is going negative 30 meters a second to the left, also west. And then we have a car going east with a speed of 20 meters a second. So here's our smaller car, and it's going to the east or to the right, 20 meters per second. And there you go. And we have completed the task. We have drawn two, which is multiple objects, and represented their initial velocities with vectors. I leave you with two practice problems. The first practice problem is that we have two cars traveling to the right at 30 meters a second and 20 meters a second, respectively. Arrange the order of these two cars such that there will be a collision. So we have two cars going in the same direction, but even when you have two objects going in the same direction, you could still have them collide. So just arrange them such they would and draw that situation. I guess I didn't explicitly write it in there, but draw that situation. Second problem is a ball is headed towards a soccer player who is traveling at 10 meters a second. They're headed in opposite directions. The idea is that the ball is moving, it's not at rest, and it's heading towards the soccer player, and the soccer player is running towards the ball. So they're headed in opposite directions. The ball is going at 30 meters a second. Draw this situation. So here we just need to be careful and make sure that you draw the negative sign on one of them. One of them is going to be a negative sign. Only one, because they're going opposite directions. Only one can be negative then.